When we get cold, just like I was at the back of the stage, the hair on our bodies stands up and we get goosebumps. Our bodies adapt to the nature around us to help us stay warm. Just like our bodies, architecture must adapt to the environment around us and to our needs, creating what we call today responsive architecture. Responsive architecture is architecture that adapts. Architecture can adapt to the environment, such as the weather, to ourselves as users, and even to itself for maintenance reasons. So how does responsive architecture adapt? And when I say responsive, you're probably thinking buildings that move, facades opening up, and even things that interact when we touch them. And you are somehow right. One of the early examples is Peter Cook's A Walking City, where the city is imagined as a nomad that keeps on crawling continuously from one place to another. When I was an architecture student as well, I imagined a moving building, an architecture school. The building would move and open up to create an exhibition space, review spaces for our juries. And once it's closed, it creates classrooms and studio spaces. But it struck me that movement alone does not define adaptation. There was something missing. So let's together take a look at these two facades, two building skins. And they both respond to sunlight. Yet one uses electrical and mechanical systems to operate, and just like my school, it needs energy and technology to move. And one uses its own material. By understanding that the direction of the wood fibers are parallel to the direction of the movement, it is allowed and able to curl open when humid and to close flat when dry. Fascinating, right? So how can two buildings responding to the same stimuli, heat, act very differently? One uses fossil fuels and one reacts by its own. One uses designed products to operate, and one operates by design. So here, at the Bahar Towers in Abu Dhabi, fossil fuels were used to move this building. Where here, at Akim Mengus, Hygroskin, the building simply moved using its own material, using Mother Nature. So why are we still relying on purely technology to create responsive architecture? Relying on technology only is unsustainable and prone to failure if the system stopped working. But nature never fails. Nature never stops working. Therefore, true responsive architecture is architecture that works like those found in nature. Like the responsive system in our bodies, it is a whole and not made of parts. The design is materially driven, and there is no need in our bodies for extra sensors to receive stimuli from the environment. Therefore, the ultimate responsive architecture is architecture by evolution. And by evolution, I mean the design evolves from the material itself. I spent my architecture career and my architecture studies trying to investigate this statement. So at the AA School in London, at the AADRL Design Research Laboratory, a team of myself and 3 other architects took a very stretchy fabric and tried controlling behavior by ridiculously pouring concrete and plaster into it. So can you imagine something as thin and stretchy as Lycra, very similar to this fabric, holding something as heavy as a building, concrete and plaster? And the funny thing is, only a single line of extra stitches made all the difference. So how were we able to do that? We went back to nature and studied the honeycomb grid. We then created a customized diagrid that enabled us to go from a saggy piece of cloth to a straight, horizontal, thin beam. And this is the same fabric mold, exactly the same as the one you've seen before. The only difference is an extra line of stitches. So an extra line of stitches made all the difference. And we were also able to control the material and create a vertical column. In collaboration with MIT, Mark West, and the Royal Danish Academy of Art, we were able to take this to a larger scale and produce a huge concrete dome using only fabric, in this case non-stretchy, but using foam. The power of material programming. So let's imagine, can we build architecture from any material if we know how to control its behavior? Very possible. But we don't have to look for a magic material. Luckily, we can only understand the behavior at hand. If we understand the substance at hand, we can create architecture. So, at Chaget Bouchon Studio at the AA School in London, we transformed a pill into architecture. And yes, a medicine pill. We used the biopolyester called polycaprolactone that comes in the form of small pellets or granules. Put it in water or heat it and it melts. You can stretch it and you can freeze it and it freezes instantly. Put it back in water and it melts again. So how can we control such a material? We did several physical and digital material experiments to control and to come up with the best structure of our bioplastic. Industrial robotic arms were used to control this behavior, resulting in a structure completely responsive in its behavior. We were able to create huge complex structures, completely stretched and extruded from our bioplastic. And at a phenomenal time, the whole structure was made of a single material. No screws, no bolts, no assembly was required. If we were to 3D print one of our average size extrusions, which is about 30 centimeters long, it would take 15 hours. We were able to achieve it in only 3 minutes. Fascinating, right? What's more fascinating is watching it stretch. We then took it to an even further step. We all know that if we can create these large structures, we can shred it and reuse it again. So we did. We shredded down the structure, melted it down, and reused it. You can change its growth or scale it up or down. And by the scale, I mean a huge column, and this column is the diameter almost of this carpet here, or to a single small beam, and this is a very small member that was used for a school facade, and this member is the size of my finger. And once you're done with this function, if you don't want to use it anymore, the best part is that you can leave it to biodegrade. So we all know that there's this need for renewable resources and ever rising in the construction industry. With responsive material behavior, we can use renewable materials such as wood in ways that has never been used before. Coupled with high technology fabrication tools such as industrial robotic arms, as you have seen before, and we can control the material in endless ways, not just by stretching. And that's what we did. A project led by the Director of Technology Lab at Perkins+Will, Andrew Jacobs, and in collaboration with Autodesk BUILD Space in Boston, we stacked 2x4 and 2x6 inches pieces of wood to achieve the ultimate automated wood construction. And because as architects, we like to drink our coffee and watch our robots build architecture for us. We didn't just stack them. We used each piece of wood as a point of force, and the connection between the stacked pieces as a network of forces, just like nature. And this allowed us to create a script. So we used technology, but with the understanding of the natural material at hand, where we could stack the wood in new ways that could form and adapt and respond to any structure you would plug into the system. We then built a prototype at the Green Build Pavilion in Chicago to demonstrate that we can change the US code to allow for high-rise buildings using only wood construction. And we succeeded. We successfully demonstrated that if we couple technology with the understanding of the nature of the material at hand, we can achieve towers completely made of wood. And by towers, I mean skyscrapers. A true revolution in design. But this design is made for us, humans. And I was always inspired by the human body. I studied its anatomy in New York, and I love drawing the human figure body. In nature, true evolution is inspired by the material itself. Therefore, my role here today is to highlight that architecture can become biological beings if we invest in the material characteristics themselves, which I believe is the only way to achieve true responsive architecture. Only then, responsive architecture can act as an extension of our bodies rather than an added built element. So when we get cold again, I hope you get architecture rather than just goosebumps. Thank you.